Okay, in this video we're going to try to solve this problem down here, and we'll see how it goes. So city A has latitude 31 degrees, 12 minutes, 17 seconds. The distance between cities A and B is 12 miles, while the length of a tunnel built between the cities is 11.9 miles. And the first thing we want to do is find the radius of the planet, and then find all possible latitudes of city B. Alright, so first thing I think we want to do is maybe try to understand the problem. So I'm actually just going to mess around and sort of solve this in general and then worry about the specific problem that we're dealing with. So what I'm going to do is I'm going to start, so this is the nsPire. I'm going to start over here on Geogebra, and I'm just going to kind of build it. So I don't actually need this grid, so I'm right clicking or two finger clicking on this and turning off the grid. I'm going to make a circle. So circle with center through point. Let's do that. So I'm going to click here, and then it doesn't really matter. So I'm going to put it here. And let's see. Let's make this bigger. Whoa, let's not do that. Okay, so click here, and then move. All right, I need a tunnel. So I'm going to use a segment for that. Click here, drag it, click here. I'm going to rename it. So click here. I right clicked on that. And then rename tunnel. Could just name it T, tunnel. But then that's annoying, so let's also not show the label. And then I also need the distance between them. So that's an arc. So that's built in. So let's click here and circular arc. And first click the center, and then I'm going to click on C, and then you go counterclockwise, and you can almost see it, and then I'm going to end at point D. So this is our arc. So let's rename this. I don't know if it'll let me name it arc, because arc is a built-in command. Let's see. Oh, I guess it does. And now if I'm on the move tool, I can grab a point and move it, and it changes my tunnel length, and it changes the arc that I get. So one thing I'm going to run into is this is not enough decimals. So what I'm going to do is if I go up to options and rounding, I'm going to go with 5 decimals, I guess, and see what we can do. So what we're trying to do is we're trying to go from knowing the arc length and the tunnel length to, I'm thinking, the radius. So let me kind of draw out what I'm sort of envisioning here. So the way I'm going to do that, let's see, is with this. All right, so I'm sort of envisioning that we'll have a kind of a circle, and then we have our arc length. So the arc length is going to be like this, and we'll call that S, and then we're also going to have a tunnel. Let's make our tunnel from like here to here, and I'm just going to call that T for now, I guess. So that'll be T. So that's T for tunnel, and then we have a, so I'm not going to get the center right, but we have a radius and a radius. So I'm seeing a couple things that I can kind of do here. So we have radius is what we're looking for, so let's label that R, I guess. And there's an angle here, which I'm going to call theta. And there's already a relationship that I can see, so based on what I've drawn, I know that theta is equal to S over R. So S over R, something like that. And now to get another relationship, what I'm going to do is add in, let's do this in whatever, this color, I guess. Let's add in the bisector. So we're going to bisect that. And then, so this will give us theta over 2. So in here, this angle now is theta over 2. And from that we can see, so it bisected the tunnel, so this length right here is the tunnel over 2. And then there's a right triangle there, and from that I can say that the sine of theta over 2 is equal to t over 2, opposite, and then over the hypotenuse, which is the radius of this thing. All right, and then there's some stuff that we can like clean up here. We can do a substitution because we know what theta is equal to. So here we know theta is this, so we can substitute, and I can get all of this works out to be sine of, so s over r over 2 is s over 2r is equal to, and then this will be t over 2r. So this looks like an equation we can definitely work with because there's actually only one unknown. So let's see what we can work out on the nspire with that. So I'm going to let the nspire do the work for us. So let's see. So we said, where'd my formulas go? Over here. Okay, so I want to solve for r. So I'm going to go with menu 3, option 1, and then sine of s over 2r is equal to t over 2r. And I want to solve for r, and I want to feed this the values that I have. So let's get the values from Geogebra and see if we get the angle right. So let me also measure the angle. So angle, 3 points or 2 lines. So I'm going to pick, I don't know, this, nope, not that. I'm going to pick angle here, point there, vertex, and then point. Okay, so I'm hoping to get about 64 degrees when I solve this. So let's go back here and feed this some values. So I'm going to do such that. So that's control equals over here. S is equal to, so S is my arc length. So that's 6.70752. And then space, and then space. The tunnel is 6.36365. And I'm going to press enter and see what. Invalid constraint. What is invalid? Oh, I didn't say. Here we go. And t equals. There we go. Okay, so this gave me r is 5.9994, and that's like pretty good because if you look at the equation of the circle, you can see r is actually 6. So let's do this. Let's put a radius here so we can measure that, and then let's rename this radius. Okay, so that's pretty good. That's, if we're rounding to 3 decimals, we definitely got it. Let's try changing it a little and see what happens. So I'm gonna move that. I'm gonna move. I don't know. Let's make it smaller. Okay, so that seems unlikely. Is it not rounding that correctly? That's weird. So it's not permanently rounding the way that I told it to round. Let's go options, round, 5 decimals. Okay, whatever. Let's keep working with it. So let's try again. But what I want to do, it'd be annoying to keep doing this. So let's turn this into a function. Let's call it radius of, we'll feed it s and t. Set equal to, I'm going to go up and grab this. I'm holding down shift as I arrow through this, like this. And then it's giving me a positive and a negative r, so I'm also, at the end here, going to throw in a such that r is greater than 0. So greater than is also in the control equals menu. R is greater than 0. So if I do radius, I have to feed it s and t. So s is 2.44156, and then t is 2.39345. And press enter. Okay, that's a mess. Let's not do that. I'm not even sure what it's doing there. So go away. and let's try that again. Get that. Okay, how about if let's put it at the end here. R is greater than 0. Okay, so for some weird order of operations reason, we have to put it there instead. So it gave me 3.53986. I think this is definitely working. Okay, so that's good. Let's go back to the original problem, if we can remember it. So for our original problem, we know that S is going to be 12, and that T is going to be 11.9. So let's deal with that. I'm going to change this. Let's get the cursor out of the way. So 12 is going to be S, 11.9 is going to be that. So it gives me R is 26.7992. Okay. I'm going to store that as, I don't know, rad, I guess. Set equal to, actually, let me do this first. So paste down, rad set equal to that. Okay. And then if I think about how radians work, if I go back to this, we said that theta is equal to S over R. So we can actually calculate the angle between them in radians now. So let's call that theta. Why not? So theta is equal to S, which we said was 12, over R, which is this radius we just calculated. Press enter. So that's the angle in radians. And I really want to do this in degrees because now let's move on to the next part, which is to find all the possible latitudes. So what I'm going to do is I'm just going to redefine it. So I don't know why I'm trying to use Q over and over. Let's say that, let's just multiply theta times, that cursor is just always in the way, times 180 over pi, right? So we're going to convert from radians to degrees. And then let's store that as theta again. So I'm going to say theta is equal to this. All right, so that's my angle in degrees. And now what I'll do is I want to work in degrees. So I'm going to change, so it's doc and then 7 and option 2. Let's change to degrees. All right, and let's make sure that theta, okay, so theta is good. And now what I want to do is I want to take the given latitude, 31, 12, 17, and I want to add theta. So let's see what I get. And then I need to convert this to degrees, minutes, seconds. So that's in catalog. If you're not immediately there, just press the letter D. Like if I press A, it bounces to absolute, and D presses here, and then arrow down a bunch until you get to convert to degrees, minutes, seconds. Press enter. All right, so I think that's one possible latitude. And then I can also subtract and then convert. And I think that's a second possible latitude. And I mean, ideally, I'd like to try to just like build this thing, but I'm not sure that I'm gonna be able to do it. But let's try. So we got a radius of 26.7. This seems challenging. Yeah, maybe I won't bother. I mean, there's a way to, we can make a circle with a center and a specific radius, so I could actually feed it the radius. And then I'd have to do a lot of things to get this completely set up. So I'm going to actually not do that. But I think we solved the problem. And so it's kind of neat. And I hope you found this helpful. And good luck.